Given the function g of x equals ax plus 2b, if x is less than or equal to 0, x squared plus 3a minus b, if 0 is less than x, is less than or equals to 2, and 3x minus 5 if x is greater than 2. Find the constant a and b so that g is a continuous function everywhere. This is a piecewise defined function where each of the part is already continuous. The parts in this piecewise function are separated by 0 and 2. For x less than 0, the part is ax plus 2b. For x between 0 and 2, including 2, the function is defined by x squared plus 3a minus b. And for x greater than 2, the function is defined by the equation 3x minus 5. Ax plus 2b is linear, so we know that it is continuous on its domain. X squared plus 3a minus b is a parabola, so we know that it is continuous on its domain. And 3x minus 5 is linear, so it is continuous on its domain as well. And so we only need to check for continuity at the point that separates the parts. At x equals 0, the limit at x equals to 0 of f of x, and then we also need to find the functional value at 0. But when x equals 0, we use the piece that has 0 in its domain, and so when x equals to 0, f of 0 is a times 0 plus 2b, and so f of 0 is 2b. For the limit at x equals to 0 from the left-hand side, the part that we would use to find the limit on the left-hand side of 0 is 2x plus 2b. And this is a polynomial, so we just simply substitute 0 in. And so we have 2 times 0 plus 2b equals 2b. For the right-hand side limit, at x approaches 0 from the right-hand side, we would have to use the formula on the right-hand side of 0, which is x squared plus 3a minus b. This is a quadratic or a polynomial, so we will simply plug in 0. And so the limit on the right-hand side of 0 is 3a minus b. For the function to be continuous at x equals 0, we would need the limit on the left to be the same as the limit on the right, which means we would need 2b equals 3a minus b. Simplifying this, we have 3b equals 3a, or simply a equals b. And so we would need the condition that a equals b, which is an equation in two unknowns, a and b. To come up with another equation so that we can solve for the system of equation of two unknowns, a, b, we will check continuity at x equals 2. At x equals 2, f of 2 is 2 squared plus 3a minus b, or 4 plus 3a minus b. We use the part x squared plus 3a minus b because 2 is in the domain of this part. Now, the limit at x equals to 2 on the left-hand side of the function, to evaluate this limit, we would need to use the part on the left-hand side of 2, which is x squared plus 3a minus b. And this is a polynomial, so we just simply substitute 2 directly into the expression to end up with 4 plus 3a minus b. For the limit on the right-hand side of 2, we would use the part on the right-hand side of 2, which is 3x minus 5. And this limit is 3 times 2 minus 5, which is 6 minus 5, or 1. Now, for the limit to exist at x go to 2, we would need the left-hand side limit, 4 plus 3a minus b, equals the right-hand side limit, which is 1. Simplifying this, we need 3a minus b equals minus 3. Thus, we end up solving the system of equation a equals b and 3a minus b equals negative 3 to find a and b. But if a equals b, using substitution method, we plugged b into a or a into b. 3a minus b, but b is a. Thus, 2a equals negative 3, or a equals negative 3 over 2. And since a equals b, b is also negative 3 over 2. And so the two values a and b that we need to find are a equals negative 3 over 2 and b equals negative 3 over 2. If a and b are negative 3 over 2, then this piecewise function is continuous.